The head of Cummins, one of the biggest names in the automotive and engine industry, has just revealed something that's creating a lot of excitement. The company is introducing a bold new idea that could eventually replace traditional diesel engines with something much quieter and cleaner. Engines powered by hydrogen. Hydrogen is the most abundant element in the universe, and now it may power the next generation of heavy-duty machines. For decades, diesel engines have been the backbone of powerful equipment like trucks, tractors, and construction machinery. They've been trusted for their strength, durability, and ability to handle demanding work. But now comes an unexpected twist. Cummins, a company built on diesel technology, is investing heavily in hydrogen engines that could potentially transform the industry it once dominated. This isn't just another new gadget or minor upgrade. It's a bold move that could completely reshape the future of heavy-duty transportation. If hydrogen engines succeed, they could challenge both traditional diesel engines and even make electric vehicle companies rethink their strategies. This development isn't a small improvement. It's a potential game changer that might push diesel technology into the background. In this video, we'll take a closer look at Cummins' latest hydrogen-powered engine and explore what it could mean for truck drivers and the transportation industry. And if you enjoy learning about new technology, make sure to subscribe so you don't miss the latest updates. Let's step back for a moment and look at the bigger picture. Think about a busy construction site, a massive truck hauling goods along the highway, or a farmer working a field with heavy machinery. That deep, powerful rumble you hear usually comes from a diesel engine. The sound is strong and steady, and it has long been the heartbeat of industries that keep the world running. Cummins has been part of that story for more than a century. Over the past 100 years, the company built its reputation by producing some of the most reliable and powerful diesel engines available. From the rugged Ram 2,500 pickup trucks to huge commercial transport vehicles, Cummins engines have become legendary for their strength, durability, and long life. These engines aren't just pieces of machinery. They've set the standard for getting tough jobs done. But times are changing. Concerns about climate change are growing, governments are introducing stricter environmental regulations, and people are increasingly looking for cleaner transportation solutions. While diesel engines are powerful, they also have a downside. They produce carbon emissions, release harmful particles into the air, and contribute to pollution that affects both the environment and human health. That's where hydrogen enters the conversation. Hydrogen is emerging as a promising alternative fuel. When used in engines, it produces only water vapor as a byproduct, meaning it releases no carbon emissions. This makes it an attractive option for industries looking to reduce their environmental impact. Cummins isn't just experimenting with hydrogen. The company is taking major steps toward making it a real solution. They've developed a hydrogen-powered engine that could significantly change how heavy-duty vehicles operate. So what exactly is happening? Could this be the beginning of the end for diesel? Cummins has long been a leader in diesel engine technology. But now the company is stepping on to the hydrogen path, and many people are wondering why. The answer is simple. The industry is changing. Demand for cleaner, heavy-duty trucks and powerful pickup vehicles is growing, while diesel engines are facing increasing pressure from environmental regulations. Governments around the world are introducing stricter limits on emissions, and diesel engines are gradually being phased out in certain areas. Take California, for example. The state has already banned many older diesel vehicles, particularly those weighing over 14,000 pounds and built before 2010. The California Air Resources Board has even announced a long-term goal to completely eliminate diesel trucks and buses by the year 2045. Cummins clearly sees where the industry is heading and is adapting to stay ahead of the curve. In a clever move, the company took one of its most well-known engines, the B6.7, which powers the famous 6.7-liter turbo diesel found in Ram heavy-duty trucks, and redesigned it to run on hydrogen. This engine platform powers some of the toughest trucks on the road today, including the Ram 2500, 3500, 4500, and 5500 heavy-duty models produced by Stellantis. By converting this proven engine design into a hydrogen-powered version, Cummins is blending familiar technology with a cleaner energy source. Instead of simply following industry trends, Cummins is trying to lead the shift toward a greener future. As diesel engines face stricter regulations and consumers demand environmentally friendly options, Cummins is using its decades of engineering experience to push hydrogen technology forward. Their approach combines trusted engine design with new fuel technology to create a cleaner alternative without sacrificing power. This move could reshape the heavy-duty truck and pickup market by giving businesses and drivers an option that is both powerful and environmentally responsible. Hydrogen internal combustion engines, often called hydrogen ICEs, offer an interesting solution for industries that need consistent high levels of power. For heavy-duty work, battery-powered vehicles sometimes struggle to meet long-range or high-load demands. At the same time, hydrogen fuel cell technology can still be too expensive for some applications. Hydrogen combustion engines provide a practical middle ground. One major advantage is that these engines can fit into existing truck designs. They can work with current transmissions, use many familiar components, and can even be serviced by existing repair shops. For drivers and mechanics already familiar with traditional engines, the transition could feel relatively natural. At the same time, the fuel they use, hydrogen, produces zero carbon emissions, making it a much cleaner option for the future of transportation. Another advantage of developing hydrogen engines is that it helps prepare the world for a zero-carbon future. By introducing hydrogen-powered engines now, companies can start building the infrastructure needed for hydrogen fuel, such as refueling stations and storage facilities. This groundwork will also make it easier to adopt hydrogen fuel cell vehicles in the future. Designing engines specifically for hydrogen also means engineers don't have to compromise by modifying older diesel or natural gas engines. Instead, they can build systems optimized entirely for hydrogen fuel. Cummins has done exactly that by creating a specially designed combustion chamber that mixes hydrogen in the ideal way, allowing it to burn quickly and efficiently. This precise combustion process helps deliver strong performance while improving fuel efficiency. Early testing results have been very promising. So how will these hydrogen engines make their way onto the roads? Cummins already has decades of experience producing natural gas engines, which gives them a strong foundation for bringing hydrogen engines to market. They are also smartly reusing many durable engine components that have already proven themselves in diesel engines. This helps keep manufacturing costs manageable while maintaining the reliability that customers expect. At the same time, Cummins is using its expertise with spark-ignited engines to introduce new advanced technologies. Their hydrogen engine program isn't simply modifying old engines, they're developing completely new platforms designed specifically for hydrogen power. These new designs include modern features such as adjustable cam systems, improved cooling systems, and reduced internal friction. The result is a powerful engine that operates smoothly and efficiently while handling demanding workloads. Looking ahead, hydrogen internal combustion engines are expected to play an important role in industries that require high levels of continuous power but still lack practical zero-carbon solutions. For operators who rely on heavy equipment running around the clock, hydrogen engines could become a highly practical alternative. This push toward hydrogen technology is also expanding the number of powertrain options available to customers. It's creating excitement across the industry and encouraging new ideas in engine development. Cummins has always been known for tackling difficult engineering challenges. Over the past century, the company has made major improvements in engine technology, reducing harmful emissions such as nitrogen oxides and soot, improving fuel efficiency, and significantly lowering carbon dioxide output. Now, their hydrogen program aims to combine these decades of engineering expertise with a zero-carbon fuel solution. The goal is to make environmentally friendly power systems practical for a wide range of applications. Meanwhile, the technology surrounding hydrogen energy is advancing rapidly. Scientists and engineers are constantly improving ways to convert energy into hydrogen and then convert hydrogen back into usable power. One example is hydrogen combustion turbines, which are being developed as a potential new method for generating electricity. In the transportation world, hydrogen fuel cell electric vehicles initially received most of the attention. However, hydrogen internal combustion engines are now gaining significant interest, especially in the medium and heavy-duty trucking sectors where power, range, and reliability are critical. Cummins is no stranger to innovation, but its hydrogen engine project may be one of its most ambitious efforts yet. The company has developed two major hydrogen engine platforms. The first is a 6.7-liter hydrogen engine designed for medium-duty applications such as delivery trucks, municipal vehicles, and construction equipment. The second is the much larger 15-liter X15H hydrogen engine, which is intended to compete directly with powerful diesel engines used in long-haul trucking, agriculture, and heavy industrial work. These engines are not just concept designs. Cummins plans to begin real-world deployment around 2027. Early testing suggests that they deliver impressive performance, producing more than 500 horsepower and up to 1,200 newton-meters of torque, which is comparable to traditional diesel engines. What makes these engines especially interesting is that they are not hydrogen fuel cell systems like those used in some electric vehicles. Instead, they are true internal combustion engines, similar in design to diesel engines, but powered by hydrogen rather than conventional fuel. Because of this, they can be integrated into existing truck platforms without major redesigns. By using many components and engineering solutions already developed for diesel engines, Cummins can make the transition much easier for manufacturers, mechanics, and fleet operators. Think of it as keeping the same familiar vehicle design, but changing the type of fuel it runs on. For an industry that tends to adopt new technologies slowly, that familiarity could make a big difference. There are other advantages as well. Refueling hydrogen vehicles can be extremely fast, taking just a few minutes rather than the long charging times required for many battery electric vehicles. The larger X15H hydrogen engine is expected to provide a driving range of around 500 miles on a full tank, which is similar to what many diesel trucks can achieve today, but without the carbon emissions associated with traditional fuel. Cummins also claims that these hydrogen engines will be just as durable and dependable as their famous diesel engines. That promise matters a lot, especially for a company that built its reputation on machines known for their toughness and reliability. In simple terms, the idea sounds almost perfect, delivering the same power as diesel but without the environmental drawbacks. So why could this become a serious challenge for traditional diesel engines? Let's take a closer look. The first reason is environmental regulations. Governments around the world are introducing stricter emission rules. In Europe, new standards like Euro 7 are putting heavy pressure on diesel technology, while the United States is pushing toward a net zero emissions goal by 2050. These policies are making it increasingly difficult for diesel engines to remain the dominant option. Because of this, many companies that once relied completely on Cummins diesel engines are now exploring cleaner alternatives. Hydrogen has quickly become one of the most promising options. This shift is already happening. Major companies such as Transport Enterprise Leasing and Versatile Tractors have started showing interest in Cummins' hydrogen engine technology. Their involvement signals that the transition toward cleaner heavy-duty power is already underway. Another important factor is economics. Diesel has traditionally dominated the heavy-duty market because it has been cost-effective and widely available, but hydrogen has the potential to change that balance. Cummins is investing heavily in the entire hydrogen ecosystem, not just engines, but also the technology needed to produce hydrogen fuel. This includes electrolyzers, which use electricity to split water into hydrogen and oxygen. Cummins is also forming partnerships that could significantly increase hydrogen production and supply. If these efforts succeed, large-scale production could reduce hydrogen costs dramatically, making it competitive with diesel fuel. There is also a powerful image factor involved. Today, many companies are under pressure to demonstrate their commitment to sustainability. Operating a fleet of hydrogen-powered trucks sends a clear message about environmental responsibility and future-focused innovation. In contrast, diesel vehicles may begin to appear outdated, representing an older, more polluting era. Cummins clearly understands this shift and is positioning its hydrogen engines as a practical solution that combines power, performance, and environmental responsibility. This strategy could deliver a strong double impact, offering both technological advantages and a greener public image. The encouraging news is that Cummins is not focusing only on engines. The company is also investing in hydrogen production itself. For example, Cummins is installing a 35-megawatt proton exchange membrane electrolyzer at a facility planned by Linde near Niagara Falls in New York. This advanced technology will produce hydrogen fuel by splitting water using electricity. Efforts like this help build the foundation of the hydrogen economy. Government support is also accelerating progress. In the United States, the Inflation Reduction Act has allocated around $8 billion to develop hydrogen hubs across the country. These projects aim to expand hydrogen production and build refueling infrastructure, which will make hydrogen fuel more accessible for vehicles. Now let's look at another impressive feature of these engines: their flexibility and power. Cummins' 15-liter engine platform is designed to be fuel agnostic, meaning it can operate on different types of fuel while maintaining strong performance. The base engine uses a specially designed cylinder head and fuel system that can run on carbon-free hydrogen or biogas. When powered by biogas, carbon emissions can be reduced by up to 19%. The hydrogen version of the engine can produce up to 530 horsepower, while the natural gas version can deliver around 510 horsepower. For applications that still rely on diesel, Cummins is also offering an advanced diesel variant capable of running on sustainable fuels or biodiesel. This version can produce up to 650 horsepower, making it suitable for extremely demanding off-highway work environments. Now imagine how this technology could transform the industry. Picture a trucking company replacing its entire diesel fleet with trucks powered by Cummins X15H hydrogen engines. For drivers, the experience might feel almost identical. The trucks would offer the same power and performance they're used to, but with quieter operation and significantly lower emissions. As hydrogen production grows, fuel prices could become more stable. Maintenance would also remain familiar since many components are similar to those found in traditional engines. Meanwhile, older diesel trucks could begin losing value. Their resale prices might decline, and mechanics who specialize only in traditional diesel systems could need new training to keep up with evolving technology. This wouldn't simply be a gradual improvement. It could represent a major transformation in the industry. The agricultural sector could also experience significant changes. Versatile, a tractor manufacturer that has relied on Cummins diesel engines for more than 55 years, is already exploring hydrogen-powered alternatives. Farmers who depend on diesel engines for their powerful torque might soon operate hydrogen-powered tractors that deliver the same performance while reducing emissions. Construction sites, mining operations, and heavy off-road equipment could follow the same path. If hydrogen technology gains momentum in these sectors, diesel's long-standing dominance might gradually fade, and the impact could extend far beyond engines themselves. Oil refineries that depend on diesel demand might face declining markets, forcing energy companies to adapt their strategies. Truck stops designed around diesel pumps could eventually transition into hydrogen refueling hubs. Entire supply chains, from diesel engine parts to fuel additives and exhaust systems, might need to evolve or risk becoming obsolete. Ironically, Cummins, the company that helped build the modern diesel engine industry, could also become the one leading the transition away from it. However, diesel technology is unlikely to disappear quietly. The industry still has strong advantages, and the battle between diesel and hydrogen is far from over. However, diesel still has a few major advantages that shouldn't be ignored. One of the biggest is infrastructure. Diesel fueling stations are everywhere. Almost every highway, city, and truck stop has diesel pumps available, making refueling quick and convenient. Hydrogen fueling stations, on the other hand, are still extremely limited. Building a widespread hydrogen network will take many years, possibly decades, and require massive investment. Until that infrastructure exists, diesel will continue to hold a practical advantage. Another important factor is proven reliability. Diesel engines have been tested in real-world conditions for decades. They are trusted by industries that depend on consistent performance. Hydrogen technology is still relatively new and needs time to prove itself under the same demanding conditions. For example, a long-haul truck driver stranded on the road because of a technical issue won't be thinking about emissions or sustainability. Their main concern will simply be completing the delivery on time. Cummins understands this reality, which is why the company isn't abandoning diesel completely. Instead, it's following a fuel-agnostic strategy. This approach allows diesel engines to remain in use while hydrogen technology gradually develops and becomes more widely adopted. Diesel technology is also continuing to improve. Cleaner low-sulfur fuels, advanced filtration systems, and hybrid technologies are helping reduce emissions and extend the lifespan of diesel engines. Some experts believe diesel will remain essential for heavy-duty applications where battery electric vehicles still struggle and hydrogen solutions are not yet fully developed. But there's an important challenge for diesel. Even as it evolves, it's mostly reacting to changes rather than driving them. Meanwhile, hydrogen technology is gaining momentum. With companies like Cummins investing heavily and governments around the world pushing for cleaner energy, hydrogen could eventually become a powerful force in the transportation industry. So the big question remains, is Cummins' hydrogen engine really the breakthrough that could replace diesel? It certainly has strong potential. The technology is powerful, practical, and capable of disrupting the industry. Partnerships with companies like Tata Motors in India, agricultural manufacturers such as Versatile, and major fleet operators show that this concept is moving beyond theory and into real-world testing. However, there are still significant challenges ahead. Hydrogen fuel is not yet widely available, production costs remain high, and diesel still dominates global transportation infrastructure. Replacing a system that has developed over more than a century will not happen quickly, but if Cummins succeeds, the impact could be dramatic. Diesel's long-standing dominance won't disappear overnight, but it could gradually decline, one truck, one tractor, and one fleet at a time, as hydrogen technology becomes more common. For Cummins, this strategy is a bold move. Instead of waiting for competitors to disrupt the industry, the company is attempting to reinvent its own technology and lead the next generation of power systems. For everyone watching the industry, it's like witnessing the beginning of a major transformation, a competition between old and new technologies that could reshape how transportation works around the world. Cummins' hydrogen engine isn't just another piece of engineering. It's a clear signal that the industry is entering a new era. It challenges the diesel world to adapt, evolve, or risk being left behind. Whether hydrogen engines completely transform the industry or simply push diesel technology to improve further, one thing is certain: the rules of the game are starting to change. So, what do you think? Are we witnessing the early stages of a hydrogen-powered revolution, or is this simply an ambitious experiment that may struggle to succeed? Whatever the outcome, the journey ahead is going to be fascinating to watch.